All right. The last thing we have here is the ear, hearing and equilibrium. We have a couple different processes here. We have the process of hearing, which we'll get into briefly, and the concept of static and dynamic movement. All right. I don't know if that's the specific words that the book uses, but that's basically what we have. Okay. Linear motion and dynamic motion. You could be moving and not moving your head, right? You could be going up an escalator. You're not physically moving, you are moving though. You could be going up an elevator. Okay. So there are a few different types of movement and motion, and it involves different pieces of anatomy. So there is a lot of wonderful questions associated with this region of the special senses. Ooh, I don't want green. I'm gonna get rid of green. Okay. So when we look at the ear, it's divided up into 3 different regions. The external ear or outer ear consists of the auricle. It's also called, let me get my little pin here. It's also referred to as the pinna. Okay. The external auditory meatus or the external acoustic meatus. It's the same thing. And last, the line of demarcation, the tympanic membrane, your eardrum. The middle ear, you can kind of see it's just an air-filled cavity within the temporal bone. You can see it houses the auditory ossicles, and ossicles just means tiny little bones. Lastly, we have the inner ear, and that's where all the magic is happening. It's where we have the cochlea, the vestibule, the semicircular canals, the vestibulocochlear nerve. That's where we're going to be having all the magic happen, to hear sound and to understand if you're moving left, right, going up, going down, upside down. All that magic happens there. Again, it's all being transmitted through the vestibulocochlear nerve, cranial nerve 8. You should know both the name and the Roman numeral associated with it. But like I said, the external ear consists of the auricle or the pinna, external auditory or acoustic meatus, and the tympanic membrane. The function of the auricle is just to funnel sound waves towards the opening. Okay, that's its only function. Okay, collect sound, funnel it into the ear hole. The external auditory canal extends to the tympanic membrane, and the tympanic membrane is the eardrum, and that's what vibrates when sounds hit it. Okay, it's going to be involved in helping to convert sound waves into mechanical energy, as we'll talk about in the inner ear and the middle ear, respectively. Out in the external auditory meatus, and meatus just means blind-ended tube. That's all it is. Okay. They don't use necessarily canal anymore because canal, by definition, you see the beginning and you see the end. Okay. Meatus means blind-ended tube, and if you've ever looked in your ear, you don't really ever see the end very well anyway. If you have a otoscope or ophthalmoscope, you can see the eardrum, and you'll be able to see one of the little ear bones just right behind it there, the malleus. So it is kind of cool and interesting, but you never see the true end of that tunnel. It also has ceruminous glands, and ceruminous glands produce earwax, cerumen. This helps to inhibit bacterial growth. It also lubricates the tube as well, and that's going to help sound waves travel through it. In the middle ear, air-filled space referred to as the tympanic cavity because it's behind the tympanum, which is the eardrum. We have a couple different membrane coverings that connect really the middle ear and the inner ear. That's the oval window. And the round window. The auditory ossicle, the stapes, is what covers the oval window, and it's oval because it's oval. Ta-da. The round window is named because it is round. Sound waves enter into the oval window first, and if there's any excess sound waves, they dissipate out the round window, okay? So oval window is where sound waves enter into the cochlea. One more structure that we have here that is associated with the middle ear is the auditory tube. It's also called the eustachian tube or the pharyngeotympanic tube. Just call it auditory tube. Super easy to spell, okay? Much easier to spell correctly than eustachian tube. So, but it is just a passageway, a tube, if you will, right? That helps to equalize pressure on each side of the tympanic membrane. That's the function of the eustachian tube. It's usually closed when you yawn, open up your mouth really wide. Air can move through this tube and help to equalize pressure on both sides. If you've ever gone up into any significant height, then you felt you felt that, and you sit there, you sit there and open your mouth, try to yawn, chew gum to get that tube to open back up, so you can equalize pressure on both sides. It can affect hearing, right? Your ability to hear is a little bit less when your ear is all clogged up like that. It connects down into the back of the throat there, went into the pharynx. So it's how middle ear infections can get down into the throat and cause a sore throat. It's how sore throat infections can get up into the middle ear and cause a middle ear infection. So, but I assume you all know that. The fancy name for that is otitis media, right? Otitis media. Middle ear infection, okay? And you can see it as a bulging tympanic membrane. You can see it as a fluid behind it. If it's ruptured, you can see the rupturing and the blood that's coming, oozing out from it there. So there's a lot of manifestations that you can kind of visualize and see it as. Meningotomy, that's what they do. They put a tube in your ears. So they'll put it in that tympanic membrane there and to get fluid to drain out of the middle ear. The reason why they do that is because children learn by hearing, okay? They see you, they hear you, they mimic what you do, they mimic what you say. That's how they learn, okay? That's why they do these meningotomies where they put those tubes in their ears. Now, what are we doing though? We are cutting the eardrum. And do things always heal 100%? No. So what does that create within the eardrum? Scar tissue. And so what happens over time, especially if you have to have multiple tubes put in your ears because your body keeps pushing them out? A lot of scar tissue buildup. And that can cause some hearing issues later on in life. But the risk, the reward is you have a little bit of hearing issues, but you don't have any cognitive delays in your development. And that outweighs the potential for having hearing issues later on in life. I had a friend, he had a bunch of them growing up. And he was, how long ago? 15 years ago when I first met him. He had hearing aids because he had so many bad middle ear infections, had to have a lot of tubes over the course of his early life. So he had some hearing issues and he had hearing aids, and he was, in his early 30s. So it can be something that develops. And then I know some other people have had multiple tubes and they don't have a significant drop off in hearing. So it happens all over the place. The last part about the middle ear is the bones. Okay. These are the auditory ossicles. Ossicles means tiny bones, and auditory means they are bones associated with hearing. They are the malleus, the incus, and the stapes. Stapes looks like a stirrup. Pretty easy. Okay. And this little faceplate right here of the stapes actually covers the oval window, which is right there. Okay. There's the oval window right there. And the footplate of the stapes is what covers it. You can see we have, we do have some muscles here. Okay. We have the tensor tympani, and we have, which attaches to the malleus. Excuse me. And then we have the stapedius right here, which connects to the stapes. So we do have some muscles up here. When sounds are very loud, these muscles, the tensor tympani and the stapedius muscle, actually contract to prevent the malleus and the stapes from creating much more bigger movements. The bigger those move, the more those move, the greater the wave of water basically within the cochlea, which we'll get to here in a second, displaces the hair cells. And that's going to cause you to hear a very, 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 very loud sound. So the tensor tympani and the stapedius muscle contract to prevent the malleus and the stapes from moving excessively so you can dampen sound. So that's their point. That's their purpose, all right? We have the malleus, the incus, and the stapes. This one is connected to the oval window. And this one is near the tympanic membrane. Okay, should probably know the order of those things. I mean, there you can see the tympanic cavity. It's not a huge space, not a huge space at all. And you can see it's within a little air cavity of the temporal bone. So sound waves get funneled in by the auricle, travel through the external auditory meatus, vibrate the tympanic membrane, move the malleus, the incus, and the stapes. The stapes oscillates over the oval window like that. And now the sound is basically converted from sound waves to mechanical energy, and we are now in the inner ear. When we look at the inner ear, it consists of that structure right there. We have the snail-like structure, that's the cochlea. This little medial portion right here is the vestibule. And we have 3 semicircular canals that go in the X, Y, and the Z axis. If you looked at those two things, okay, you can see we have an outer bony part called the bony labyrinth, and labyrinth just means maze, right? And I guess if you're first looking at this, I guess it looks like, you have a weird snail end and you have a weird bump in the middle, and then you have these 3 canals going in the X, Y, and the Z axis. I guess it looks like just a big maze. So that's how it got its name. But this bony labyrinth is there to protect. The receptors that are basically deep within. Okay. It is filled with a fluid that is called perilymph, and you should probably know that. Okay. The fluid that is just underneath the bony labyrinth is called the perilymph. Deep inside these bony protective pieces are what is called the membranous labyrinth. Okay. And it is a membranous fluid-filled tube. That's all it is. Okay. That's all it is. But what they house all the receptors for hearing and equilibrium. And here you can see the membranous labyrinth is pink. There it is. There it is. All of this here is the membranous labyrinth. And we have receptors for both equilibrium and hearing, all housed within that very delicate membranous structure. It is filled with endolymph. And it's different from perilymph in that it is rich in K, potassium, right? This is something that's very different and very unique. This endolymph has a high amount of potassium. It's the influx of potassium that's actually going to trigger the magic to happen. Okay. What have we always talked about? An influx of sodium. This is the only one where we have a huge influx of potassium that leads to a depolarization event. It's the only one where potassium is causing a depolarization event. Potassium is the main dude. It's the only dude. Well, that and calcium, but potassium is what triggers it. This is vastly different from everything else that we've looked at, where it's always been sodium, right? So do you see where people can easily screw up some easy points here? Of course you can. Potassium, 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 potassium. And again, three major regions: the cochlea, the vestibule, and the semicircular canals.